Hello, I'm ILVA XHAFERRI from grade 12C and I'm going to talk about origami, the math of folding. Origami is the art of paper folding. The aim is to transform a square sheet of paper into a finished sculpture by only folding it using different techniques, but never cutting it. Origami is a Japanese word. Ori means folding and gami or kami is paper. The roots of this form of art date back to the Edo period in Japan, as shown in the painting that depicts children playing with the famous origami crane. But how did simple figures like this evolve into these intricate designs? The secret formula for these amazing models is something really unpredictable: mathematics. Art and math came together to form complex and lifelike paper structures with a single sheet of paper. The first to lay the foundations of modern origami was Akira Yoshizawa, also known as the Grand Master of Origami. Not only did he introduce 50,000 new models, but also created a common language of instruction to be followed by origami artists all over the world. By studying the mathematical principles behind this art, people can now create new models that are even more detailed. Robert J. Lang is a former physicist who left NASA in order to concentrate only on his origami works. He is one of the first origami artists and theorists. In his books and public talks, he explains that origami is formed using crease patterns that have to obey four simple laws. You can color each crease pattern with just two colors without having the same color meeting. At each vertex, the difference in the number of mountain folds and valley folds is always 2. If you line up all odd-numbered angles, they will add up to 180 degrees. Even-numbered angles are also supplementary to each other. No matter how many times you try to stack folds and sheets, a sheet can never penetrate a fold. Origami is not only used for aesthetic purposes, it has many applications in every branch. Solar panels for satellites and spacecraft, shades, mirror, telescope lenses, etc. These are objects that, in order to be transported safely to their destinations, must have a small size and then be able to unfold into large surface areas. An example is the Miura Ori, an origami tessellation created by the Japanese astrophysicist Koryo Miura. This design makes it really easy for the panels to be intact during the flight, and once stationary, incredibly easy to unfold. Applications of origami are also in fields like medicine, with small ingestible robots that unfold once inside our organisms, and many other uses, like the airbag folding into a proper form. In conclusion, origami is not only an art form that pleases the eye of the viewer. Like other cases where math is involved, origami can have many applications, from space travel and exploration to microscopic devices to heal wounds and diseases. It is our duty to not waste its potential, but to use it in our favor.